Welcome everybody. Welcome everybody to the second day of FSFM 2025. So for today's session 3, we have Dr. Tapan Kumar Raut, who is principal scientist and head of functional materials at Tata Steel Limited. And after his PhD from IMMT, which is Institute of Minerals and Materials Technology, Bhubaneswar, he started his career in Tata Steel Group, India. Now he has been a leading scientist in the field of material science and corrosion and has been working for last 25 years. He has his works published in 120 reputed journals and has 51 high quality patents to his credit. Now, so far, hello, hello, hello.
Yes, ma'am. Carry on. Carry on.
Okay, sir. So far, 7 students have been awarded PhD degree under his guidance, and he has received national awards from various organizations for his contributions, namely National Young Metallurgy Award, Mineral Excellence Award by Indian Institute of Mineral Engineers, and Dr. 𝗕𝗵𝘂𝗋𝗚 National Award for Excellence in Electrochemistry. Thank you, sir, for your precious time. So please share you. So please explain.
Okay. So actually the network is very poor. So it is very difficult for me also to, because I am in Kolkata right now. Okay. So
Okay, sir.
that's why the frequency is very, very poor. But I hope you can hear my voice.
Yes, sir.
Am I right?
Yes,
Okay.
sir.
Okay. So so my talk is on, can you go to the first slide?
Okay, sir. Okay, sir.
So how long I should speak?
Sir, for 1.5 hours actually the time.
Okay, well, 7:30 up to 7:30.
Yes, sir.
Okay. So my talk is on a plan to lead in materials transformation. And the talk is mostly connected to our Odisha related materials. So thank you, Ismita, for introducing me for this conference. I'm very much thankful to Dr. K.K. Das and particular to you, Dr. Susri Pita, for organizing these frontiers in semiconductor and functional materials.
Thank you so
So
much, sir.
how the material transformation is happening recently? So that is the thing I will cover. And what are the future trends in the materials that highlights I will give for the audience to think through. So go to the next slide. I've given one picture. So how the minerals present in their own. No, go back. Yes, this
So
picture.
this one.
Yeah, make it in full screen.
Yes, sir.
So here just I would like to highlight here that how the minerals in the nature. You can see over here the minerals, they are present in different ways in the earth crust. So primarily they are composed of, the earth crust. The major 8 elements, that oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. And they are in the form of silicate forms or non-silicate forms. Okay. So these silicates are called the locking particles. They locked the valuable minerals. You can see from the picture, pure minerals you see it is in black color. And this pure mineral is coated with the young particles, nothing but your silicates. And it's very difficult to separate. And sometimes The valuable minerals are also coated over the gangue minerals. And these gangue minerals, when you separate out, they are very fine particles. It is very difficult to separate or liberate. Therefore, they are in the different phases called composites. So minerals with the gangs, valuable minerals with the gangs, they are in the form of composites. And 50% of your minerals are logged with these silicate and non-silicate phases. And it's very difficult to separate out of that. And these materials or the minerals are linked to their geology or composition of their original ore or rock sources. And gangue particles, are the commonly worthless impurities. That is called sand or mud or other earthy minerals mixed. And they are in the different forms, in the form of silica or sulfides. And to separate it out, lot of mineral process that have been developed. So people using different called the techniques, the flotation techniques, grinding techniques, and magnetic separation techniques. Lot of techniques they follow to separate it out. And the slime particle, nothing but your fine particles, is the challenge to separate it out to get the valuable minerals, because the fines have high surface area and very poor settling behavior and negatively impacting efficiency by increasing different reagents or different chemicals to treat, to remove to get the valuable minerals. So techniques like hydrocyclones or adsorbent, they use for recovery. And once you recover, the waste management, again, another challenges. So if you see the state of these minerals, where we are in terms of the state, the Odisha, go to the next slide. So go to the next slide, Smita. Yes. So you can see over here, minerals, they are the fundamental natural occurring solids, which is different crystal structures. And so far, 3,000 minerals have been identified. And only about 30, they are most valuable and evident in terms of, you can say, silicate and non-silicates. So silicate minerals, nothing but quartz, feldspar, mica, and olivines. And non-silicate, they're calcite, hematite, pyrite, gold, etc. You can see the different state they are dominant in terms of their presence. You see the Rajasthan, the mineral and metals are there. And you see the Gujarat, chemicals, ceramic, their presence, their textiles, they're dominant in terms of their business linked to this. And also in the Maharashtra, you can see. So all the states, what I have shown here, that they have their own identity in terms of minerals or materials. And in Odisha, though we have reached with the different minerals, but so far we have not put our footprint in this map. The trends, if you see over here, the energy materials, EV, defense and aerospace, dots where we can lead, because the source of the materials and minerals, they are from Odisha. Go to the next slide. In Odisha, you can see the most valuable minerals. I categorize corresponding to different districts, but majorly we are dominating iron ore, coal, and also in rutiles, the titanium and manganese, and also quartz and gemstones, and also graphite. we are richer in this type of minerals. And if you see over here, all these minerals are associated with the gang particles or gang minerals, you can say. So we have the institute in Odisha, the Institute of Minerals Material Technology. They are working a lot to extract the valuable materials out of this ore by different techniques. And they are also transforming the technology to different companies through the research and developments. And by seeing the dominance in the materials and minerals in Odisha, so we have a lot of opportunity to do. Next, go to the next slide. So if you can see over here, the major source is the chromite, 80% of Indian reserve, and bauxite, again, more than 60%, iron ore, manganese, also nickel, ebb and graphite, and gemstones, around 17% of total mineral reserve in India. And we also do a lot of exploration in the PGM materials, called platinum group materials. Platinum, palladium, rhodium, ruthenium, this comes under that. And also rare earth elements. So you know the beach sand is the source of the rare earth elements, and also the Indian Rare Earth Limited IRE. They are also doing a lot of exploration for getting the rare earth elements from the minerals. And after seeing all these, what is called the available valuable elements for us. So nickel is one of the major elements being used for the different energy applications. And the source of nickel is from the Odisha, from the chromite overburden is around 3 to 4%. So challenges over here, the mineral beneficiation and extraction of these elements from the waste. And technology are there. It's not a bottleneck. We have enriched knowledge from the different labs and also universities. And followed by this, I can show you how we do by using the manganese as a resource utilization and production for high performance magnet and battery materials. Go to the next slide. So you can see over here the manganese I highlighted over here. If you see the manganese, you know the manganese the abundant in the 𝗕𝗏, 𝗤𝗏, and Raajdhani district of Odisha. And this is a very special element, materials for the battery. And one, you know, the manganese and the electrolytic grade of manganese, the importance in the currently that but can you please switch off? Some background sound is coming. So electrolytic manganese metals, and that is a very demand for the electrical vehicle, for the battery manufacturing. And we are rich in that segments. So a lot of opportunity before us by understanding the feasibility of a production and also understanding of their characterization. As you know, that manganese has also very good capacity in terms of anode materials. So we add the value to this manganese products. And I have given some business objectives over here. The cost from the raw manganese to the highly called the electrolytic grade manganese. So there is a quantum jump in terms of the cost. So So the thing is that we have to develop the capabilities and regulatory framework to understand how to map this manganese upscaling to the applications. And it is required because we don't have any regulatory body in Odisha that is called innovation regulation body, so which can think of that the high amount of manganese should not use as a commodity product, but that can be used as a specialty product for the energy segments. So another example I have given in the next slide, that is on the, you can go to the next slide, that is on the carbon materials and silicon carbide. If you can see over here, we are rich in this graphite minerals. And graphite, to make different form of graphite, colloidal graphite, nanographites, and graphite flex, and from graphite to nanomaterials called graphene, is a two-dimensional carbon particles arranged in hexagonal pattern. This has got high surface area and high electrical conductivity, also high thermal conductivity. And this is being used for different applications in the battery as well as in the supercapacitors. And we are rich in that. One company in Bhubaneswar, they are producing this graphene from the graphite. And this is a huge opportunity for us. The application of this graphite and graphene oxide for the composite coating materials and for the ink conducting ink applications. And similarly, another materials are silicon carbide. Silicon carbide, they are used for the semiconductor applications. As you know, the future trend, the semiconductors. So silicon carbide, we are there. Technology is not at all a bottleneck. The complete know-how with us, and a lot of spin-off companies, they start applying to do this business of producing silicon carbide. And it's important, again, hint towards this, manage how to manage the innovation social regulatory body in Odisha. So if you see my chart over here, the raw graphite to the specialty graphite, the cost is 100 times. So there's a lot of opportunity over here. So you can go to the next slide where I have given another example. The rice husk can be used for a valuable product for us. You see over here, one product, I've given one example, that is called the polypyrrole. You know that polypyrrole is a conducting polymer. You know that conducting generally polymers are electrical insulator. And this polypyrrole, when it is polymerized, it is conducting. So polymer can be conductivity. So this polymer development has got Nobel Award in year 2000. In year 2000. So they surprisingly see that polypyrrole, polyaniline, these are the class of polymers. They show the electrical conductivity. So where you can get this polypyrrole? Polypyrrole you can get from the pyrroles. The where you get the pyrrole? Pyrrole you get from one monomers. That monomers can come from the rice husk. So this rice husk, you can oxidize, and that oxidized product, it is water soluble, and get this derivative, and you polymerize, you get the polypyrrole. You can understand the rice has a cost 85,000 rupees per ton, and if you make a polypyrrole, it's a 10 lakhs rupees per ton. You see the business opportunity for us. Now we produce a lot of rice husk in our state, so one can think of producing the high value product from the rice husk. So go to the next slide where I've given the outlines over the critical minerals. So you can think of copper, nickel, cobalt, platinum group metals, and rare earths, titanium, tungsten, or lithium. I will just give you a kind of overview over here. A lot of these materials being used for the magnetic materials and energy, and also for the water purifications, and also for the pigment industries. One example I can give you, zinc. So when you do the zinc coating, zinc in the hot called the molten state, and that molten state act as a coating. So you can protect steel by using the zinc coating. But when you do this zinc coating, so in the bath, the molten bath, a lot of floating mass you can see observe. That is called a dross. And this
Hello. Hello, sir.
hello, can you hear me?
Yes, sir. Yes, sir.
Okay. So up to now you hear, or it was mute?
No, sir. No, sir. Only for 5 seconds.
Okay. So this
Okay,
zinc dross. So zinc dross are nothing but your is a composition of a zinc with iron and with a little bit silicon. That dross floats on the molten zinc bath, and the dross can be utilized for the making the zinc sulfide. You know that zinc sulfide is a very good pigment or act as a fluorescent materials being used in the coating for the road signing. You can see over, you see some sort of a fluorescent paint in the road. They do the road marking. So that road marking paint is a composition of zinc sulfide, and also some other pigments they are used, but zinc sulfide is a very low cost and also give this kind of a colors. So one can synthesize this zinc sulfide from the zinc dust, zinc dust, and lot of opportunities for the downstream business by taking the waste product, what are mineral after beneficiation to the valuable materials in terms of called energy or coating pigments, or for making the filler for the composites, and many areas one can think of using this waste, the valuable products. So I have given few downstream business. Go to the next slide.
கொஞ்சம் போட்டா போதும், ரொம்ப சுகர்னா சுகர் கம்மியா தரப்பட்டிக்காங்க.
I go to the next slide. Yes, you can see over here some of the downstream business opportunities where one can think of making the steel for the structural and steel for the structural applications, and also steel for called the strips as a color coating products. And also one can think of what we can do for the semiconductor industries. And I can give you an example over here that in case of steel for the structural applications, and that is called the rebar. You might have heard or seen, or constructing a building, you must be using the rebar called a rod of different diameters. And this rebar is coming in a, go to the next slide, please. This rebars coming in a different forms. So that are coming coming in a coated rebar, or coming in a fiber rebars, or stainless steel rebar, and also with the zinc coated rebar or galvanized rebar. So all this we do to enhance the life and the strength of the rebar, which can be used safely for the construction segments.
யாருக்கு என்னன்னு கூட கேள்வி கேட்க மாட்டோம். அவ்வளவுதான்.
Please, ma'am.
Hello.
Hello, please, ma'am. Mute yourself.
வணக்கம் மேம்.
Can
ஏன்
you
நீங்க
hear me?
பாட்டுக்கு அடுத்து
You can see over here that epoxy coated rebar. You can see in a green color rebar in the market. It looks like a green. So whole purpose of this coated rebar is to protect the steel from the corrosion, early corrosion. And this coated rebar can be used in the coastal areas where you can make the construction in the water or in high moisture or chloride atmosphere. And similarly, the stainless rebar and the called glass fiber reinforced polymer rebars, they are being used for road constructions and cladding purpose. And recently, the new development is happening over using the carbon fiber, where you can get the high strength as well as the light weight. So to make your building lightweight and also to enhance the life of that building by using this kind of advanced materials. So one can think of, if you see the bare rebar cost and the coated rebar cost and the epoxy coated rebars, one can think of doing a business for making the coated rebar out of these black rebars. So another downstream I have shown over here, next slide, called the color coated streak. So you can see in this slide, lot of color coated product in the market. All the substrate, they are steel and steel with the zinc or aluminum coatings. And over that, you can do a lot of prints. So we are here telling you that the printed steel, so like your textiles is coming in different prints. So here the steel will be different prints that can be used for fancy applications. Make your building very decorative, inner and outer side. And all these materials are high durable. So you can get the life of 100 years, depending on the polymer and the materials as a coating being used. So you can see one example I can give you that you can see the fancy door of a refrigerator or Godrej door, almirah's doors. They are with a different prints and they are high durable, and they are nothing but is a polymer that printed over the steels. So this is not a special polymers. This is conventional or standard polymers with different pigments, and that we give a lot of colors and we textures during the process. We process in the line is a continuous coating lines, and we call it the color coating lines. You might have visited steel industries where they are producing this kind of coated product of different colors. So this is a very big opportunity for the downstream business who wants to be entrepreneur in this field. They can take the steel strip from the steel industries and make a print on the substrate and sell in the market. And you can see the projection of steel cost to the profile cost. It is completely, it's highly, you can see the valuable in terms of business. Go to the next slide. I will give you another opportunities on the electronics applications for the semiconductor industries. As you know, currently this semiconductor is going in a very weak way. A lot of R&D investment also happening around that. So what I can tell, I can hint it over here that the semiconductor that started with around 19th century and discoveries by Farad on silver sulfide resistance. And that is being evolving with now the quantum physics, leading to different invention of a transistor from the different labs. The most famous lab is the Bell labs. They are from germanium, and that is being replaced by the vacuum tubes, and lot of generation happening over different years. And again, start off with the silicon revolutions in 1954, followed by the invention of the integrated circuit. And now you can see to this Atmanirbhar Bharat programs, or Startup India, Startup Odisha program. A lot of spin-off companies, they are thinking of doing this kind of what is called the business, starting with the materials and characterization as well as the equipments, and the assembling circuit from solution into different plastic or fibers. So that part also, the material point of view is evolving. And when you talk about the semiconductor, the most important materials people are talking about the silicons. And seeing the silicon, the doping chemistry is making a big role in that. So to make it a P-type or N-type, depending upon the different dopants. So the revolution is over here, that synthesis and purity, and also the joining technology, how to make the junction, the joining, and after that you make the different chips. So as you know that in the integrated circuit, or the next slide. So now this is the advanced equipments people are using to make the monolithic. Go to the next slide. Monolithic. Yes, this is the equipment. So where you can do the lithography, and you can billions of circuit diagrams you can make out of small materials. So the technology has evolved around this semiconductor field, and billions of these transistors that can be etched onto a single silicon chip, and to perform the complex calculations, forming the super computers, memories, and sensors, etc. So electronics materials, as you know, that substance that being used to build electronic devices, they have been classified by their electrical properties, like conductor, insulator, or semiconductors. Is the foundation for everything, from computer chips to the LEDs. Key types include the semiconductors like silicon, as I said you, for integrated circuits. Like that, another materials, next slide please, gallium nitrates. The gallium nitrates, that is for the LED, and different magnetic materials for storage, and specialized, you can say, ceramics and polymers for various components. The materials really driving the modern technology. So semiconductors, as you know, that the silicon, is being dominated. You can also tune their you can see the properties, and therefore it's very crucial for the electronic application. So their ability to conduct electricity, so the control by adding, you can say, the dopants, and that dopant addition, and make the materials out of that can be changed. They're very sensitive to different temperature and as well as the light. This makes them ideal for building transistors, diodes, and integrated circuit for computer chips. And that power computers, phones, and modern technology, allowing for miniaturization of and speed, etc. So what is the innovation over here? Innovation is that how to make it smaller and make it faster. Go to the next slide. And reliability. So these are the, you can say, the innovations is happening around this. Make it smaller, faster, and reliability for the electronics applications. So there are a lot of companies, they are working for the different, what is called, the manufacturing of these semiconductors. So next slide, please. Go to the next slide. So yes, you can see over here different companies, major semiconductor manufacturing companies I have mentioned over here. TSMC, Samsung, Intel, NVIDIA, Micron also there. So all these companies, they are not doing everything. So set up companies, they focus on the manufacturing of the chips, and companies that are focused on the supplying the equipments, and also companies do the special characterizations. So it is a complete evolution is around this called the manufacturing of semiconductor materials or quantum dot materials. So this
Hello. Hello, sir. Hello.
Disconnect ହେଇଛନ୍ତି. Hello.
Oh,
yeah.
hello.
Hello, can you hear me now?
Yes,
Okay.
sir.
Yes,
Yes, sir.
sir. Yes, sir.
Okay. So as I mentioned you, these are the companies, they are focusing on their specialty or capabilities. Okay. So recently in our country, the few companies, they are putting their setup. Micron is one example, and also Tata is also doing setup in Bangalore as well as in Gujarat. And this segment is increasing and increasing or expanding through a very good called the value chains through, because a lot of funding agencies and the financiers and also the different universities and institutes. And you can see this semiconductor is providing the opportunity for a lot of startup companies. They can think of bringing a lot of new things in terms of materials, characterization equipments, and also designing, because designing also another area. There is also a lot of investment people are doing, and also a lot of organizations that are also working on it. Go to the next slide, please. Yeah. So you see, whatever I said so far, the materials innovation for the energy segments, defense, or coating applications or structural segment, etc. The most important is the R&D investment. So R&D investment in research and innovation that fuel the economic growth and competitiveness and new solutions. So involving that fundamental research, that new knowledge you can say, and applied research, the practical usage, and development, the creating product and processes. If these are the things can be thought through in a very good value chains. One can think of the making the innovation into a reality. That is real the innovation. Globally, you can see a lot of nations like India, they significantly putting their efforts and focusing on increasing the private sector R&D. And the private sector institutes, they are doing excellent in other nations because they do the fast research. If you fail fast, then you can think of making a success soon. So they are leveraging this lot of schemes in other nations. And our country also boosting this innovation through different ways. So you all know that. But the most important thing is that if you do a lot of research, if something is not coming into the market as a breakthrough product, so that means the whole efforts what we are putting. So one can think of that we are either required in a different way to look at, or something more required. Some more required means more help in terms of funds, or help in terms of knowledge is required. That gap has to be properly defined. Otherwise, we will be working in the R&D, but getting a breakthrough will be a nightmare. So go to the next slide. So here you can see that I have given one snapshot over here to see how much our lot of countries are investing on where we are. So if you see, we have no presence. I have given, you see the list of 10 top industries, what they invest in their R&D. Okay. So as a country, as a citizens of our country, we have to think what is the gap, how to bridge that. Go to the next slide, please. Yeah, you can see over here. You know that the any country in the world, those are doing the innovation or the technology development, they have very strong defense segment. So what I am saying here, that your innovation is driven by the defense segment mostly. So in our country, you see, recently the last 4 or 5 years, we are putting a lot of investment in the defense segments. Therefore, you can see the lot of spin-off companies are came up. So in that way, so we have to bring that material innovation as well as the innovation in the defense segment, the business. So here, there's different segments I have given over here. These are the segments really that will drive the innovations. And then the people or researchers, scientists, technologists, they can be given challenges where they can focus on. They are focused on the material development, characterizations, or design, or think of some modeling as well. So these are the opportunity before us when one segment that is defense segment, if it will grow in our country. So go to the next slide. So we have lot of CSR labs, lot of DRDO labs. We have lot of DST labs. Apart from that, we have lot of IITs, NITs, and also state-run institutes. We do lot of work. We do lot of innovations. But we all do in a silo. Therefore, it is difficult to know each other. So the gap is there to connect and collaborate and share the knowledge. If you think in that way, what will happen? We can shorten the time of development, and we can bring the lot of novelty onto the surface. The strength of intellectual property, what I have given over here. What we do generally, we talk a lot, but whatever we are talking or discussing, if any institute or labs, they focus on doing some prototype development or a proof of the concept, POC, they should immediately file the patent. Even you can do patent filing, your design, also your ideas. And the role of the IPR department here, they should play a big role. They should also, all the institutes, they can think of that in that way. So how the ideas, things can be protected. And also, that should be a business development in the different institutes required, which can think of the commercialization of the product or processes. And as you know, all this product development runs through different TRL, technology readiness levels, TRL 0 to TRL 9. You know that development we call it a funnel. So TRL 0 to 1 means it is your concept, your ideas. And TRL 2 to TRL 4 means prove the concept in the lab. And 4 to 7 is called the prototyping or piloting. And 7 to 9 is called the product pilot, called the plant scale trials and launching the product in the market. So this funnel, it has to be seen in a very holistic way by all the organizations, all the labs, either private or government. So then only we can think of bringing a product from lab to the market. So that is what I am saying, the TTA, Technology Transfer Assessment. So how strong we are in that, something has to be looked by their chiefs or their lab or institute head in a very holistic manner. So come to the next slide. So here I have given one examples, you can see. So opportunity, we have to create ourselves. So we are, as a Odisha, I can tell you that we are sitting on the minerals. And we don't have any called the finished product is coming out from the Odisha and going outside. What we are selling? We are selling the raw minerals. The value addition is very rare in our state. So this is high time for us. So as a citizen of our state, country, and belongs to the Odisha, we should work in that way where a lot of companies or government should fund us, fund the institutes. They can think of creating the incubation center in their institutes. So where a lot of opportunity will come to the students. So students, they should work and they should train and develop their skill so that when they will pass out from the institute, they have the ground knowledge, what they can offer, what they can do, what they cannot do. So this incubation concept, they are in all other nations of the world, but we are making, but we have to make it in the policy that institutes, they should have the incubation centers or the state of art labs where they can do the concept test and think of the business opportunity afterwards. So I have given one our example of a business incubation, operating business, corporate research center, and Odisha research labs. So Odisha, there is no what is called that regulatory body, called an innovation regulatory body in Odisha. In Europe or in Western countries who are developed, they have their own called the research commissions, and they control and they funds and they also do market the innovations. But we required in our state like Odisha, where we are sitting over the lot of valuable minerals. As a team, we should approach. As a team, we should work towards that. And I have been in touch with different people, and I am promoting that the concept of called the Odisha Research Park or Odisha Research Labs in a different private or government organizations in the name of Odisha only, so they can focus on the materials, innovation around that. So go to my next slide, last slide, I hope, yes. Yes. So this is the, I have given the conclusion. The Indian industry invests 0.3% of the gross domestic product in in-house research and development, compared to the world average of 1.5%. It's a very big gap. We have to do a lot. Second, India spends only $7 billion annually on industrial R&D, compared to $625 billion in the USA, and $335 billion in China, and $130 billion in Japan, and $90 billion in Germany. If you can see where we are in terms of R&D. India is the world 5th largest economy and manufacturer, but ranked 21st in industrial R&D. Our 10 most successful non-financial firms have a very healthy profit by world standards, but invest little in R&D, a mere 2% of a profit. By contrast, firms in the USA, China, Japan, Germany invest between 29 to 55% of their profit in R&D. To put this in a perspective, 25 individual firms, starting from Alphabet to BMW, invest more in R&D than all Indian firms combined. So one can visualize that why they are developed and we are aspiring to become like them. So better, we should not follow them. We should lead in the front by bringing everybody together. Thank you very much.
Thank you so much, sir. Any questions? Dear participants, do you have any questions for sir? Hello, do you have any questions? No questions? Okay. Thank you so much, sir. On behalf of the organizing committee, I extend our sincere thanks to you for your insightful and engaging talk.
Hello, wait, ma'am. If anybody asking any question,
Okay,
please.
okay. Sir, chat.
Yes. Yes, ask. If anybody having any question, please ask.
ಇಲ್ಲಡ ಮೇಡಮ್ ಬಿಟ್ಟಕ್ಕೆ ಕಡೆಗೆ ನಾವು ಅಂಗಡಿ ಅಪ್ಪ
Okay, ma'am. Ma'am,
Hello?
give word. Thanks to sir. Vote of thanks to sir.
Okay, sir. So thank you so much, sir. On behalf of the organizing committee, I extend our sincere thanks to you for your insightful and engaging talk. And thank you for giving us this harsh reality check that our Indian R&D on our Indian R&D development. So thank you so much, sir. Your valuable expertise and clear explanations have greatly enriched this FTP and provided meaningful learning to all participants. We are truly grateful for your time. Thank you so much, sir. Shall I stop staring?
Yeah, thank you very much, Susri, and thank you very much, 𝗲𝗏𝗃, for giving this opportunity.
Sir, we are very much thankful to you, sir, because you have given your time, valuable time from your busy schedule, sir. Sir.
Yeah.
Forever, sir. Thank you, sir.
Thank you so much.
Okay. Thank
sir.
you. Then I will sign up.
Yes, sir. Yes,
Sure,
sir.
Okay.
Okay, sir.
Okay, ma'am. Next. Hello, ma'am.
Hello. Yes, sir.
If next speaker is available, then ask them to join, and we will continue it.
Okay.
Okay.
Okay, sir. I'm
Ask
asking.
him. Please ask him to join. Dear participant, we will start your session 2 right now. Please stay and join.